Good morning, guys. Okay, in this lesson, we will learn real life context of graphs. Why will you use the graphs in real life, or how can you use it, and what is the reason of using the graphs in a real life? We usually use it to make our daily life easier. Okay, so for example, in this diagram, as you see, 1 minute. Okay, where is my pen? Okay, and it's here. So first of all, let's read the definition of in these units. So graphs give information in a visual form, okay, in a short form. Therefore, they are often used in real life contexts because they can be easier to interpret than a table or chart. So the numbers uh, on the axis can represent almost anything. You will usually see a different variable on each axis. Often, one of the axes will show time. For example, in this diagram, which line is our x-axis? Of course, horizontal line. Okay, so this axis, x-axis, or this straight line called x-axis, and a vertical line called y-axis. Okay, don't forget. And sometimes we'll use for this straight line the time, but here they used kilometer or distance. Okay, read any labels on the axis and look at the scale careful to see what the intervals on each axis stand for. And I've worked example. Let's look at the worked example, and then after that we have some examples for you. I mean, it's useful and exam time also. It will be helpful for you. So this graph shows fares charged by two different taxis. Okay, the first taxi is taxi A and taxi B. Okay, but their distance, their costs, and their time also different. So what is the question of A? How much does each taxi charge for a journey of 7 kilometers? So let's calculate separately for each taxi. For example, let's start with the taxi A. Now it's the point of zero. We need 7 kilometers. Where is 7 kilometers? 1, 2, 3, 4, 5, 6, and 7 is here. Okay, after 7 kilometers, the cost of taxi A is, and as you see here, $14. Okay, it's cost dollars. So after 7 kilometers, the cost of taxi A $14. And okay, the option of A, the answer is 14, as you see here. And B, option B, or the second taxi, what is the cost of taxi B after 7 kilometers? And here it's crossed here, and approximately it's 11 or 11.5. I mean, it's 11. Yeah, so we'll take the how can I say, integer numbers, and between 12 and 10 we have 11. That's why the cost of taxi B after 7 kilometers, $11. Okay, so find the cost coordinate where the distance coordinate is 7 coordinated to 11 for taxi B, and a 7 coordinated to taxi A is $14. Okay, second option B, how much does taxi A charge for each kilometer? Taxi A, where is taxi A? Started from $0 from 0 kilometers. Okay, and we need how can I say, how much does taxi A charge for each kilometer? Each kilometer for 7 kilometers we have, and the cost is 14. That's why we can use the simple way, 14 over 7, because $14 to 7 kilometers. Okay, its cost or dollars is equal to $2 per kilometer. Okay, so taxi A For 1 kilometer, the charging $2. And taxi B, there is no question of taxi B. Okay, option C. Or let's read the explanation. And 1 kilometer costs $2.2 for 2 kilometer costs $4 and so on. So 1 kilometer per kilometer, and the taxi A charge about $2. And C, taxi B has a fixed charge and then charges a certain amount for each kilometer. Okay, the question one first, how much is the fixed charge? It's $4. Why? Let's show it. Where's taxi B? Taxi B is here. Okay, it's starting with $4. When you see the taxi, okay, it's starting with $4. And okay, after 1 kilometer, it will take approximately $5. Okay, so $5, and after 2 kilometer, he'll take from you $6 taxist. Okay, so and as you see here, $4. If the distance is 0, the charge is $4. Its started point is $4, and to 1 kilometer costs $5. That's why 2 kilometer cost is $6. 3 is 7 because it started with the $4 for each kilometer. Uh, he'll charge from you per $1. Okay, so how much each in kilometer? It's $1 for each kilometer. And D, what distance will cost the same amount in either taxi? The same amount. Okay, same amount. Same amount. It means it's cross by cross, and the cross where they'll cross the $8 and 4 kilometers. Okay, so they will cross 4 on the point 4 kilometer, and their how can I say, cost also same per $8. Okay. Okay, let's open the next page. There we have some questions. And the first question, the first exercise, Zalika and Tanisha are cycling on the same road. Okay, on the same road. So x-axis, our horizontal line is time, as you see here, time, okay, and 24-hour clock, and a distance of our y-axis, okay. So the graph shows their journeys, and Zalika started at 9 o'clock in the morning, okay, in the morning, 9 o'clock p.m. And what time did Tanisha start? So Zalika started at 9 o'clock, and Tanisha started after 30 minutes from Zalika. Okay, so Tanisha started at 9:30 o'clock. And how far did Zalika travel in the first hour? Zalika, where is Zalika? It's first journalist. Okay, after 1 hour, in the first hour, so she started 9 o'clock, and after 1 hour, she'll be here, or 10 o'clock, and she will take how many kilometers? Of course, 20 kilometers. Okay, the coordinates 10 to 20, because it was x, it was y. So x-axis is equal to 10, and y-axis is equal to 20, and it's crossed here. So how far did Zalika travel in the first hour? She will travel at 20 kilometer per how can I say, 1 hour. Okay, so let's see, how long was Tanisha cycling before she caught up with Zalika? Okay. How long was Tanisha cycling before the caught up with Zalika? Tanisha cycling of 1 hour, in 1 hour, because she started 9:30, and after 1 hour, 10:30. Okay, it's Zalika's journey. Sorry, Tanisha's and Zalika's. They have meet at the same point. Okay, and the same. It's 30 kilometers. Yes, that's one of after 1 hour Tanisha after 1 hour بعد ذلك after 1.5 or 1/2 hour they'll meet at 30 kilometers. Okay, and question 2, Lucas is driving from Iton to Bibury. Lucas is driving from Iton. Okay, where's the Lucas is here and Bibury is here, and Lucas started from Iton. Okay, yes, Iton from Iton, and Simon is driving from Bibury to Iton. It's opposite of Lucas. The Simon is started from Bibury to Iton, and then Lucas started from Iton to Bibury. Okay, so what is the question? How long did Lucas take to get to Midley? I mean, it's 1.5 hours. Why? Why? Because how long did Lucas take to get to middle? Where's middle? Midley is here. Lucas started from point of here, okay, and started here. And after how many hours he'll get to Midley? And as you see here, the time of Iton, okay, distance of Iton and Lucas's. Sorry, not Iton, Lucas and Simons. Okay, so after 1.5 hour, or Lucas went to Midley in 1.5 hours. Okay, 1.5 hours. Lucas went to Midley 1.5 hours. Okay, because the between 1 and 2 is whereas we have half 1.5. There's no written. Okay, the second option B, the second question, how long did Lucas stop at Midley? And as you see here, that Lucas stopped some time, okay? And how long it's? How long? From here, it's if you started to stop here from 1.5 and 2, 3, of course, the difference of 1.3 and 3, 1.5 to 3, of course, 1.5. Or Lucas stopped at 1.5 hours, okay? And C, how long did Simon take to get from Bibury to Iton? Okay, where's our second man? Simon is here. Okay, it started from Bibury to Iton, and how many hours he'll get their route or journey. Okay, so there's we have time from 0 to 5 hours, and from Biber, or what is the distance from Biber to Iton? Of course, 300 kilometers, and Simon travels 300 kilometers by 5 hours. Okay, by 5 hours because it's started point and the initial point is okay. Initial point and final point is 5 hours. So Simon arrived from Bibury to Iton is 5 hours. Yes. And the last question, D, how far were the cars from Bibury when they passed one another? Okay, I need the map of their cars journeys. Okay, so I mean it was 125 kilometer because if you start to calculate from here, okay, from I-10 to cross points, you will see 175, okay, because between 100 and 200 it's 150, and this point means 175, okay, 175 kilometers. So if you calculate from I-10 to uh, not middle, so cross it or pass it one another because they'll cross here, and that's why one how can I say car pass it another one to here. So that's why this point, I mean 175 if you calculate from here. Okay, so but we need from Bibury to here. So we need the distance of between Bibury and 175. So the initial point is 300, and the final point is 175. So between we have 125 kilometers. Okay, so it was 125 kilometers from Bibury, and when the car passed one to another. Okay, and question 3, Razi and Jake are running laps of a running track. How do you know from the graph that Jake is running faster than Razi? How can we know it? So Jake is faster than Razi. Where is Jake? Jake is here. Okay, he started after Razi. Okay, so between them have 2 minutes. So and first of all, Razi started from initial point, the 0, and Jake started from second minutes. Okay, so how can you know? Jake is faster than Razi. If you look carefully from the second minute to fifth minute, we have 3 minutes totally. Okay, and 3 minutes, in 3 minutes, Jake traveled how many laps? 2.5 between 2 and 3. It's 2.5 approximately. Okay, 2.5, maybe 2.4, maybe 2.3, but we will take the between 2 and 3, the value of between 2 and 3. Okay, at the same time or the same minutes, 3 minutes, what is the Razi's from 0 to 3? Okay, in 3 minutes, Razi's laps only 2. That's why the Jake is faster than Razi. They are the same time, the Jake run 2.5 laps and the Razi is only 2 laps. Okay, how long had Razi been running before Jake started? Before Jake started, he was running 2 minutes. Yes, the Jake started after 2 minutes of from Razi. And where were the runners 9 minutes after Razi started running? Razi started from 0 after 9 minutes. Okay, they'll meet. Okay, they meet the same points. Okay, the same points or 6 laps. As you see here, they cross it in 6 laps. Okay, and here we have question. And the last question, it's last question. Please look carefully. At 13 o'clock, Shan leaves home on a cycle ride. Okay. If you draw the table of their performance, the horizontal line will take the time. Okay. Time about hours, and vertical line you will take kilometers. Okay, so y-axis is kilometer and x-axis is time. Okay, so hours. Okay, so Shen left what time? At 13 o'clock. Okay, it's 13 o'clock afternoon, 13, and by 15 he has traveled 35 kilometers. So it's 35 kilometers here, and he has traveled. Okay, he has traveled. Or how can I draw it? I can draw like this, for example, because it's not the same way. Okay, approximately is here. Okay, so because in each time their performance is not same, different. For example, the first 5 minutes his speed is different. Okay. So this 35 km from 13 to 35 km to how many time from initial point to final point? We have 2 hours. Okay. So 2 hours. What time is it now? Now I mean the time is after 2 hours we have 15. Okay. So that Shan left home at 13 o'clock, and she has traveled 3 o'clock afternoon, uh, 35 km. Okay, she stops for one whole 1 hour 1.5 hours. Okay, she stops. Sorry, he stops 1.5 hours plus 1.5 is equal to 16.5. Okay, plus 1.5 is equal to 16.5, or the afternoon 4:30 p.m. Okay, and okay, he's right now here, and then cycle back, and the cycle back to home. He arrives back home at 18 o'clock. 18 o'clock. He'll come back to home. There's we have 18 o'clock. Okay, in the evening. In the evening. So what time? What's the difference of between 16.5 and between 18? Of course, 1.5. So the same distance, 35 km, but not same time. Okay, when he will go to the, how can I say, target point, it will get at 2 hours, but he'll come back to home, it will get 1.5 hours. Okay, so it's not same. And okay, so what's the question? Show this journey on a graph. Put time on the horizontal axis and distance from home on the vertical axis. Okay, already we have done. It's x-axis our time, and the y-axis is our distance. Okay, and B, at 13 or 15, 15, Shen's sister leaves home and cycles after him at the same speed, but she leaves home not the same time, but she leaves the home is at 15 o'clock afternoon p.m. So his sister now leaves home the same speed. Okay, same speed to target approximately here, and because 2 hours the time maybe plus 2 is 17 is here, approximately is here. Okay, and the same speed, show this on the graph. So this one is Shan's sister, this one is himself, Shan, and their journey is the same time, also distance is same, 35 km. And okay, what's the option C? B also already done. Okay, she leaves home at afternoon 15 o'clock. The speed is same. She will arrive about 17 o'clock. 17 o'clock, because also her brother, little brother, was arrived at the same time. Okay. So last one, how far from home will they meet? Yeah, it's very important. How far from home will they meet? Okay, so if you look carefully, when his sister started from home to target point, okay, target point at 15 o'clock. At 15 o'clock, where have been her brother, or Shan? I mean, Shan was here because after 2 hours, he was here, and after 1.5 hours, he was here, and after 1.5 hours, that Shen's brother approximately will be here. And if you calculate the kilometers, you will get approximately 24 kilometer. Okay, when she leaves the home, and after 1.5 o'clock, she will be here approximately, and after 1.5 o'clock, he will be here, and they'll meet from home to 24 kilometers. Okay, when you calculate, you will see because he was here 1.5 hours, and his sister also started from home at 15 o'clock, and she'll come, and here they'll meet at 24 kilometer. Okay. Thank you for your attention.